Whether my screen is visible?
Yeah, it's visible.
Okay. So as I said, so today's topic is going to be the carbon and its compound. So basically, carbon and its compounds are very easy, but then only if you understand the concepts, this topic is going to be easy. So basically, carbon compounds are nothing but they are called as the organic compounds. So there are so many types of organic compounds in nature, and hydrocarbons are one among them. So we can also say that hydrocarbons are the very basic ones, and they are the fundamental ones from where the types of carbon compound starts. Okay, so today in today's demo, so we're going to learn what is an hydrocarbon and what are the types present there. Okay. Okay, so the first one is hydrocarbon. So hydrocarbon, as I said, so they are the very fundamental type of organic compounds. So the compounds which contain carbon as well as hydrogen in them, they are called as the hydrocarbons. Triti, whether my screen is visible? Am I audible?
Yeah. Yes,
Okay,
ma'am.
okay, fine. So the compounds which contain carbon as well as hydrogen in them are called as the hydrocarbons. So here you can see a structure where carbon as well as hydrogen are present, and there are small black dots present here and there. So now can you tell me what are those? Do you have any guess?
They show the bonding electrons.
Yeah, great. So they are nothing but they are the electrons which has been shared between the carbon as well as the hydrogen. Okay, so if you see between two carbon atoms, there are four electrons, which means that there are two bonds present there. So basically, for a bond to be present, there should be two electrons shared between each of them. So here, since four electrons are present between both of the carbon atoms, it means that there are double bonds between the carbon atoms. Okay.
Okay.
And the next is the definition of hydrocarbons. As I said, so the compounds which contain carbon as well as hydrogen, they are called as the hydrocarbon, and they are also a type of organic compounds. The starting one, the very fundamental type of organic compound is the hydrocarbons. So now we are moving into the classification of hydrocarbons. So basically, hydrocarbons are classified into two types. One is the open chain hydrocarbons, the other is the closed chain or ring cyclic hydrocarbon. So the first one, open chain hydrocarbons, are nothing but the arrangement in which carbon and hydrogen are present in an open chain, that is, they don't have a closure, both the ends of the chain are left open. So that is what we call as the open chain hydrocarbons, and they can be classified into two types. One is the saturated and the other one is unsaturated. So
Unsaturated.
do you know what is meant by saturated hydrocarbon?
Saturated hydrocarbons are when all the free radicals are filled. So you can't.
Anything else?
Uh, I
Okay.
don't remember the exact
Okay,
term for
okay,
it.
no problem with it. So saturated hydrocarbons are very simple. So in case if a structure is given to you, and if you find only single bonds all over the structure, then they are known as the saturated hydrocarbons.
Hmm.
So the compounds in which it contains only single bond is present, then those compounds are called as the saturated hydrocarbon. So a hydrocarbon in which the carbon atom is linked to other only by a single bond, that is, you can see only single bonds between each of the carbon atom, then it is going to be a saturated one.
Okay.
And the name of those compounds are called as the alkanes. So alkanes are compounds which contain only single bond in them, and here you can see there are two carbon atoms and only one bond is present, right? So if only
Mhm.
one bond is present, then how many electrons are involved?
Two.
Very good. So only two electrons are involved. If only one bond is present between two carbon, then it is known as the alkane. And alkanes are nothing but they are saturated organic compounds, that is saturated hydrocarbons. And the second type is unsaturated one. So unsaturated ones are nothing but if there is a presence of double or triple bond between two carbon atoms in a structure, then they are known as the unsaturated hydrocarbons. They can be classified into two types, alkene and alkyne. In case of alkene, you can see two double bonds between the carbon atom, which means four electrons are involved. And The other type is alkyne. So here you can see 3, and in case of 3 bonds, then it means that 6 electrons are involved. So in all these 3 names, you can see that the first 3 letters are same, right?
Yeah.
Only the last 3 letters differs in each of them. So that is the trick. So ANE, ENE, and YNE. So all these 3 things differ only in the last 3 letters. The first 3 letters remains the same. So this is the open chain hydrocarbons and their classification. So before we start with the naming and IUPAC nomenclature, so we have to be very clear with this concept of open chain hydrocarbons. Only then we can move forward with the IUPAC nomenclature. So first, I'm going to tell you what is an alkene. So as I said, only the last 3 letters are different in each of them. So that is why it is highlighted here. Alkene, alkene, and alkyne. So alkenes are nothing but the compounds which have single bond in them. And alkene has a double bond and alkyne has a triple bond. So the general formula of alkenes is CnH2n plus 2. So in case if you are going to substitute 1 in the place of n, then what will be the formula?
Uh, CH4.
CH4,
4.
right? So then it is going to be methane. The name of that compound is methane. Okay. So if it contains 1 carbon and 4 hydrogen in them with a single bond, then they are known as methane. And the next one is alkene. So if you compare both these structures, you can see that 2 electrons, that is 2 hydrogen, is less in alkene compared to alkane. And when we go back to this, when we pass on to the alkyne, there are still 2 hydrogen less than the alkenes. Okay, so the number of hydrogen keeps on decreasing when we move from alkane, alkene, and alkyne. Okay. So this is the general formula, and this is how you elaborate with your homologous series. Okay, so when you're going to write your homologous series, then what you have to do is you have to make use of this formula and you have to substitute the numbers in each of these formulas where you will get the homologous series of each of them. Okay,
Yeah.
so the next one is in alkanes, as I have said, it is a single bond and double and triple bond. So as I said, alk is common for all. So it represents, it is the root word. So actually, whenever you're going to write an IUPAC nomenclature, that is whenever you're going to write a name for the compound, so it should have 3 parts. One is the prefix, the center one will be a root word, and the third portion will be the suffix. So prefix will always contain the substituents. Okay, the substituents which is going to be present in that structure, and the second one, which is the root word, it always indicates the number of carbon atoms, and the last one will be the suffix, which will indicate the bonds, the bond which is present inside that structure, and also it represents the functional group also. So these are the things which you have to keep in mind when you write an IUPAC nomenclature. So those things could be learned later. But now I'll tell you, if only 1 carbon atom is present, then how you will write the root word. That is the centermost part of the IUPAC name. Okay, if you find a compound with only 1 carbon, then you name it as meth. Meth. So then it is, if it is going to be 2, then it's eth, and it goes on like this. Okay, so now this is going to be common for each and every type of open chain hydrocarbon, but the last 3 letters will differ. Okay,
Okay.
so now you can see. So we have read about the general formula for alkanes, right? CnH2n plus 2, which means that CH4 is for methane, and here you can see that there are 2 carbon atoms and 6 hydrogen around them, but the name has been given as methane. Is that correct?
No.
No. What is the name of it?
Ethane.
Yes, exactly. If it is going to be 3,
Propane.
yes, exactly. Okay. So you can see that a single bond is present between two carbons, which means that two electrons has been shared between each of the carbon, and hydrogen is sharing one electron with the carbon.
Hmm.
So each of them are sharing one electron between two of them. That is why a single bond is formed here. Okay.
Okay.
So if we go towards the alkenes, which says that there are two bonds which are present between the carbon atoms. If you see a structure like this, then you can easily say that it is a alkene. So because two bonds are present between the carbon. So we all know what is the valency of carbon, Triti?
Four. Four, right?
4. Okay, 4. Okay, now you can see how many bonds are present around each of the carbon atom. Can you count me and tell? Can you count and tell me?
Two with H and two with C, so four.
So 4. So which means that each of the carbon atom is sharing 4 electrons with the other elements which are around it. Okay. So if you take one carbon, it is sharing its valence electron with the other carbon atom as well as with the other two hydrogen. That is why a double bond as well as two bonds with hydrogen are formed here. So this is how a ethene looks, which means that there is a presence of double bond. That is why we give this name as ethene. The name is ending with ene, which means that there is a double bond present in the structure. Okay, so the third one is ethyne. Okay, ethyne is nothing but there is a presence of triple bond in the structure. So that is why we call it as ethyne. Okay,
Yeah.
so now we are going to learn in detail about alkanes. Okay, so now as I have told, so we are going to learn about the homologous series. So the first one is CnH2n plus 2, which is the general formula of alkenes. So if you substitute 1 in the place of N, then you get the formula CH4, which is nothing but methane. And if you're going to substitute N with 2, then what will be the answer?
Uh, C2H6.
C2H6, it is ethane, right?
Hmm.
So this is the electron dot structure of methane. So now what did you understand with this structure basically?
Uh,
Hmm.
there's one electron from hydrogen that's bonding to one electron from carbon. It's the
Exactly.
same thing with all the other
Yeah,
hydrogen.
exactly. So electron dot structures are nothing but it represents the electrons. That is how many electrons are shared between each of the atoms. So that is what it has been represented through the structure also. Here you can see there are 4 electrons around the carbon atom, which has been indicated by X, which means that there are 4 valence electrons around the carbon. And the valence electron of hydrogen has been indicated by the dot. So the carbon is sharing one electron and hydrogen is also sharing its one electron. So which leads to the formation of a bond between carbon and hydrogen. So at the end, we get the structure called methane, CH4. Okay.
Oh, yeah.
So here also you can see there are 4 electrons. Here each of the diagram represents only the valence electrons. So because we all know that the atomic number of carbon is 6, right? 6. When you classify, like when you arrange it in an electronic configuration, then there will be only 4 electrons in the outermost shell, which we
Hmm.
call it as valence electron. So that has been represented by this pink electrons here. Okay. And all these 4 electrons has been shared with each of the 4 hydrogen atoms here. So that is why we have written that in an electron cross dot structure as methane.
Okay.
Okay.
Yeah.
So you can see that this is how they share the electrons and they form a structure together. And if you're going to substitute n is equal to 2, you have already told that it is going to be ethane, right?
Hmm.
So ethane has 2 carbon in it and 6 hydrogen in it. So which means that each of the carbon is sharing one electron with the other carbon as well as 3 hydrogen atoms here. So that is how the structure comes. The next one, n is equal to 3. If n is equal to 3, then C3 and H8, right?
Hmm.
Propane. So
Yeah.
propane is nothing but if a compound has 3 carbons, then they are called as propane. If it has 4, then it is going to be butane. So this is the electron dot structure, electron cross dot structure of propane. And n is equal to 4, it goes like this. And this is the cross dot structure. Okay.
Yeah.
Okay, so the next one is the unsaturated hydrocarbons. So unsaturated hydrocarbons are of two types, right?